Today we're going to talk about three different simple machines: the inclined plane, the screw, and the wedge. So let's talk first about the inclined plane. So the inclined plane makes work easier, like every simple machine, by creating a longer distance for the object to travel while still accomplishing the same amount of work. So in this situation, I have a 10 Newton weight here, and I want to lift it 3 meters into the air. If I wanted to do this, we know that work equals force times distance. So my force is 10, right? I need 10 newtons of force to lift this up. And my distance is 3 meters. So my total work would be 30 joules. So if I wanted to make this easier for myself, I would use an inclined plane. An inclined plane is basically a ramp. So let's look at it now. If I took the same 10 Newton block and I placed it at the edge of the ramp and I pushed it along the ramp or inclined plane, now my force is going to decrease because look, I'm still going to do 30 newtons of work. You can see that here, but 30 joules of work, which is here. But what's going to happen is I am going to basically use a larger distance. So instead of lifting 3 meters, I am basically pushing 6 meters. So my distance is now 6, which means my force can be a lot less. I only have to push with 5 newtons of force to move the same size weight up to the same height. So let's look at it again. If I were just to pick up the box and put it at the 3 meter height, I'm basically going to have to use 10 newtons of force to make that happen. But if I were to push it along the ramp or the inclined plane, then I only have to use 5 newtons of force. I had to use half of the amount of force because I used an inclined plane. So let's watch this video of inclined planes to get a better understanding. So one important thing they said was the longer the distance of the inclined plane, the less effort you need to use. So basically, the longer the ramp or the inclined plane, you don't have to push as hard on the object. You use less force. Another thing I want you to think about with an inclined plane, let's think about if you're rolling a shopping cart full to the top with groceries. So you have your shopping cart and you get to the steps. Now, usually staircases, they'll have one set of steps and then a ramp next to it. Which is easier, to lift that full shopping cart up the steps by picking up the shopping cart or rolling the shopping cart up the ramp? Your answer should be rolling the shopping cart up the ramp. Because the ramp increases the distance, you have to use less force to do the same amount of work. So that's basically how an inclined plane works. Now a screw, if you think about it, a screw is a simple machine that's basically an inclined plane wrapped around a straight line here. You've taken that inclined plane and you've wrapped it around. What a screw does is when you put a screwdriver in the top of a screw and you're spinning it, you are applying a force in this direction. It's rotating like this. But by doing this, you are increasing the distance that you're using because instead of just pushing straight down, you're now going around the screw. And since you're increasing the distance, that means you have to use less force. So if you think about it, using a screw would be much easier because you're going to use less effort. So think of using maybe a screw versus a nail. A nail, you're just going to hammer into the ground. If you're going to hammer a nail, you have to put all the force you need into that one hit downward. If you use a screw, the rotating screw there, there's more distance. So what happens is by using the screw, you decrease the amount of force you need. What do you think is going to take more strength or force? Hitting a nail with a hammer or spinning a screwdriver in a screw? Typically, spinning the screwdriver will be a lot easier than trying to hammer in a nail. Some other examples of screws is a spiral staircase. Or some construction vehicles will use this as well to drill into the ground. It's much easier to drill into the ground with this spiral mechanism or a screw because you're increasing the distance, so you're decreasing the force. If this were just a straight line, it would require more force to go into the ground. The next simple machine I want to use is a wedge. So what happens with a wedge is basically you have an object and you push it down between two other objects. So let's think about a wedge would be like this axe here. You're applying a force downward, but actually the force is getting pushed outwards, like so. So there are many examples of wedges in society. You may see them when maybe you're fixing a flat tire. What you do is you'll stick the wedge underneath the car and crank it, and what it'll do is you don't have to lift that entire car. Think about how hard it would be to lift that car in the air. The wedge increases the distance, so you apply less force. So basically what that means, instead of having to lift up that whole car, you've increased the distance so you don't need to apply as much force to get the car off the ground. So let's watch this video to summarize this.
Wedges and screws. Mr. Douglas is making a wooden table and some chairs for the backyard with the help of some simple machines. In this topic, we shall learn about the wedges and screws. Mr. Douglas is using the log to make the table. He needs to chop the log into smaller pieces. To cut the thick log of wood, he has to use a lot of force. To make it easier, he is now using a simple machine, the wedge. A wedge is basically an inclined plane. Wedges may have one or two sloping sides. Now let us see how it works. With a knock of the hammer, Mr. Douglas has pushed the wedge into the log. Notice how the effort of pushing it in has caused a spreading force and split the log into two halves? This happens because the force of the hammer pounding on the flat end of the wedge drives the sharp end of the wedge deeper and deeper into the wood. Having cut the log, he needs to scrape off some of the uneven surface with a chisel. A chisel is also a type of wedge. It uses a forward driving force and turns it into a sideways force. The plank is now ready, and so are the legs of the table. To assemble the table, Mr. Douglas is using screws. Look at the screw closely. It is an inclined plane wrapped around a cylinder. Like a wedge, a screw moves into the material. Look, after an initial tap on the head of the big screw, Mr. Douglas is turning the screw. A screw turns a small rotational force into a larger forward driving force. He is also using some smaller screws to fix the leg properly. The inclined plane of a screw can be steep or shallow. That is, the threads can be far apart, as in a big screw, or close together, as in a smaller screw. The difference is, the farther apart the threads, the faster a screw moves into a material with each turn. But it takes more effort. Looks like the table is almost ready. And with this, we conclude our lesson on wedges and screws. Summary. Wedge is a simple machine. It is a type of inclined plane. Wedges can be used to split things apart. Screw is another simple machine. The screw is also a type of inclined plane. A screw turns a small rotational force into a larger forward driving force.
So basically what that video told us was that both the wedge and the screw are technically examples of an inclined plane. The wedge is going to take that force down and turn it into a force out. Think about if you were to try and rip apart this log yourself using your own hands, you would need to use a lot more effort than if you used a wedge. When you have the wedge in place, what you can do is you don't have to apply as much effort going down for the log to split apart going out. For the screw, on the other hand, the force you are using is in a rotational way. So the force is rotational, but it is getting turned into a force downward. So what's happening here is in all of these examples, you're increasing the distance and you are decreasing the amount of force that you need to use. And that's it for these three simple machines.